This is my solution for the problem that we did on Friday of week 1. And we were talking about a dipole. So we have a positive charge and a negative charge, and we were going to find the field along the line that bisects the dipole. And so we had, say, a distance up h from the axis and a distance down h from the axis, and we'll call this charge as both q. And so if we choose a point on the bisecting line and ask ourselves what's the electric field here, we have to add 2 vectors. So along the line to the 1 charge, there is a repelling electric field, and the line from the negative charge, because we always put a positive test charge at this point and ask ourselves what would the force be on that in order to find the direction of the electric field, this electric field actually is attractive. And so what we realized is that by the symmetry of the problem, by symmetry, we realized that the horizontal components cancel. So what that means is that the total electric field, the sum of the electric field, is, so let's see, I'll write it like this. So E total is 2 times each separate electric field due to the plus and the minus, but only in the y direction. Okay, I think that makes sense. So the trick is now to get the y components of the electric field. So the y components, just, I need to make my little triangle here. If I want the y components, if this angle is theta, then this angle is theta. So the y components would be sine theta. So it's 2 times the magnitude times sine theta, where the magnitude is always k, q, all over the distance from the charge to the point you're wondering about, squared. So if the point is out at some distance x, this is h squared plus x squared. But of course, we don't have sine theta in the problem that as it's given, and so I use the geometry to show that sine theta is, let's see, sine is opposite h over the hypotenuse, which is x squared plus h squared again. And so I'm left with that the electric field is 2k q all over h squared plus x squared, and sine theta is h all over the square root of x squared plus h squared. Oh, I should have put those two together. Okay, and that's the answer. Now, the way a dipole electric field is usually expressed is in terms of this combination with the 2 and the q and the h. So q, the charges, times the distance between them, 2h, is sometimes called the dipole moment. So we can write this as the dipole moment, P divided by h squared plus x squared. You know, the other thing I can think about too is what about very far away? And in fact, very far away then, the h is much smaller than the x, and what that means then is that it goes to something like k, p, all over x squared to the 3/2. We can really just not worry too much about the h, and we're just left with the x. So we have x cubed And you may have encountered in another class that the distant limit of a dipole field goes as the distance cubed. Okay?